Today we're going to discuss the Measures of Variability, section 1.7 in our textbook. Our three measures of variability are range, standard deviation, and the interquartile range.
I don't think you're recording.
The range of a distribution is the distance between the minimum and the maximum. It's a single value, so we do the maximum minus the minimum. If we take the data from our travel times, the minimum is 5 and the maximum is 85, so our range is 85 minus 580. Standard deviation. Okay, another measure of variability or spread. It measures the typical distance of the values in a distribution from the mean. We use S with a subscript X to abbreviate standard deviation. We also sometimes see the Greek letter sigma. This is lowercase sigma. In Algebra 2, we used uppercase sigma for sum. To find the standard deviation of a quantitative set, it can only be quantitative. With n values, n is the number of data values, the first thing we have to do is find the mean. Remember, x bar is our abbreviation for mean. We calculate the deviations. How far is each data value from the mean? So that's x, your data value, minus x bar, the mean. Then we're going to square those deviations. Because if I added up all the deviations, I would get 0. Because the mean is the middle, right? The mean is the center. So I have to square them to make those negative ones positive, and then I'll add them up and divide by n minus 1. And then, I don't know why that's not on here, we take the square root. We are going to use the data from McDonald's fish and chicken sandwich fat content to find the standard deviation. Okay? We found the mean of this data the other day on Wednesday, but let's do it again. So step 1, find the mean. 19 plus 22 plus 20 and we're going to divide by 9, right? Yes, because there is 9 data values. And you can do that in the calculator. You can turn back to your notes from Wednesday and tell me what the answer is. It was 22 point what? 22.11. So my mean is 22.11. So for each of those data values, we're going to make like a little table here to keep it organized. Okay? 19. $17. So this is X. Okay? We start with our data. Then we subtract each of those values from the mean. So X minus X bar. So the first one is 19 minus 22.11. Gives me negative 3.11. That's really hard to see in the black, isn't it? Then my next value is 22, so 22 minus 22.11 is negative 0.11. Take a second and find all of the deviations. So we should be subtracting the data value minus the mean. It's always minus the mean. 26. Hold on. Okay, so if I just take the deviations and add them up, I get 0, basically. I got 0.01 because we rounded the mean to 22.11. So if I took it without rounding and added them all up, I get 0. So I can't just take the deviations and add them up because that number 0 does not tell me anything about how spread out the data is, right? It's not 0 because 0 would mean all of the data is the same number, and that's not what we have. So in order to deal with the fact that we have positives and negatives, and if I add them up I'm going to get 0, we square them. Because there is no undoing an absolute value. Okay, so we can't use absolute value because it's not as useful as a function as the square is. So the next step is to square all of them.
Are you serious?
Yes.
Oh. You don't like those.
Then we square them. I could have given you the list of data from the first slide that had like 20 values. I give you 9. You can handle it. Square them, write it down.
Take the square.
We're finding the square of all of those deviations. 5.89 squared. 3.89 squared.
Why are we putting so many like decimals?
We try to keep, when we're doing calculations with decimals that keep going, we want to round as little as possible because every level that we round at, we take away more accuracy. We're rounding, we're chopping off a bunch of numbers, and that removes some of the accuracy and we get farther and farther from the true value. So we want to, as a rule, keep 3 numbers behind the decimal point as we're doing these calculations. Okay? If we round to the 10th place, it's going to be quite a bit off from the actual value. Yes. I forgot one. Oh. In here, negative 1.11 is 1.232. Thank you. Okay, so we found the deviations. We found the squared deviations. And now we're going to find the average, thank you so much, of those values. So we're finding the average deviation from the mean. That's your standard deviation. So we're going to add these up and divide by, now we divide by n minus 1. Okay? It's complicated as to why we just do. Okay? So let's add this up and find the sum. Or sigma. Remember, sigma means sum. So let's add them up. I got 670.882. Yes. And we're going to divide by n minus 1, which is 9 minus 1, 8, right? Divide by 8.
What sounds good? Oh, literally, I'm so tired. I wanted to be like 4 last night. It's the best.
So the value I have just found is s squared, the standard deviation squared, which is called the variance.
I got 676. Because she added more. She added 4 places after this. I got 670.
You're going to have a little bit of a difference depending on how you rounded, right? And I actually wrote all the numbers down, and then some of them I didn't put in the calculator when I added it up, right? Because I told you to do 3 decimal places, and then I started writing down 4, so I didn't add some of those decimals in there. Is it close? Is it 270.8 something? I mean, sorry, 670.8.
Yeah, I got 670.8 or 888.
Close enough. If you're off in the thousandths place, that's not a big deal, right?
Wait, so
Right. That's when I divide by 8.
600.
We're going to take the square root of our variance. Now, let me show you a little bit of calculator. Okay, sorry. This wasn't recording, so it wasn't going to show up in the video. Hit second and then the square root button. It's above x squared. And then if I hit second answer above the negative, I don't have to retype that whole number. I can just have it take the the square root of that, and I don't have to round either. Then I get a more accurate answer when I use that key. So my standard deviation S of x, is 9.518. 3 numbers behind the decimal point. Oh, sorry. Why am I messing up my numbers today? 9.158. Yeah, I don't know. Okay, so then what does our standard deviation mean? Okay. Standard deviation means on average. Okay, for this example, what I have underlined is the content, the context. On average, the fat content in McDonald's fish and chicken sandwiches varied from the mean 9.15 grams. That's what our standard deviation means. This is how we interpret. Here are some characteristics of standard deviation that are important. Measures of spread are always positive. The standard deviation of 0 means that all of the data values are the same. A larger value for Sx indicates greater variation from the mean. Standard deviation is not resistant to outliers and extreme values, so it will be changed if you add outliers or take them out. And we should only use standard deviation in conjunction with the mean, because we needed the mean to calculate standard deviation, not the median. So mean and standard deviation go together, and then we'll talk about how median and IQR go together.